Good evening, ladies and gentlemen. This evening I want you to get used in the habit of going backwards in time very fast. We're going to start about 2,500 years ago and accelerate backwards to about 1 million years in less than 60 minutes. And I calculate that that's about 15,000 years per minute. And we're going to do that underwater, and I'm going to zigzag about the world from continent to continent, visiting every landmass except Antarctica, so I hope your geography is pretty good. Underwater cities are not just the preserve of alternative archaeology or people who believe in little green men. If you were on holiday in the Mediterranean and saw things like this underwater, blocks of stone squared off, the tops of doorways and arches, sloping stone walls, or huge jars, pithoi, embedded in the seabed, you would quite correctly assume that either the sea level had changed or the land had sunk. That anomaly, which has changed, is going to run right through the talk this evening, and it's a much more difficult thing to solve than you might imagine. I started my PhD in 1960, and at that time I was interested in trying to see how one could use Roman and Greek and Phoenician classical ports to measure the sea level change around the Mediterranean. I constructed an inventory, by the time I'd finished, of about 1,100 classical cities, and they're not all underwater, but obviously if a city is built on the waterline with docks and jetties and breakwaters and so on, the footings of many structures are in the sea. So that from this, and from the buildings such as mosaics or temples or roads which had to be on dry land, you could work out the change of sea level. Examples, that's Caesarea on the coast of Israel, and this is the Crusader fort, but that's the ancient breakwater built by Herod, with all sorts of concrete structures and jetties there. These are divers in Israel working on the remains of Caesarea. And this is a reconstruction of a typical classical port. I made a little sketch drawing for it, and a commercial artist put together this very nice visualization where you've got the military port here with slipways and triremes and so on, and fortified entrance, a fishing port, which is much smaller, and a big commercial harbour for grain vessels and so on. This is the life I love. Libya, 2003, and we've got the ruins of Brak Notar in the sand, two desert-converted Toyota Land Cruisers. Our children, Peter and Kirsten, are in there somewhere, and Jay, and the drivers getting ready to make a fire for lunch, and me working on the notes. It's hard work. Okay, Ficus, this is on the coast of Libya. It's a site which I first visited in 1959 and made this map, which as far as I know is still the only reasonably accurate map published of it. You can see these extraordinary structures, rock cuttings, huge incisions in solid rock, leaving things rather like roads with rooms and, in this case, a little sort of temple with an offering inside a little niche. And nobody really has a clue what it was for. The channels here are flooded. It's probably submerged by about 2 meters. Along the shore, we have Apollonia, which I first visited in 1958. This photograph was taken in 1957 from a military helicopter, and this whole area is the flooded town, and that's the outer harbour, that's the lighthouse, and these are the slipways. This photograph was taken through polarizing sunglasses to cut out the glitter in the water. The perspective is rather misleading. Because of the angle, it makes it look as if the island's very close to the shore, but that's about 500 or 600 meters. You can see the tops of the slipways along here. There's a row of buildings here, which we call the 9 Keys, and the sandy floor of the harbour basin is in there. Those are Kirsten's fins on the right and my feet on the left. I don't wear fins. And you can see the foundations of a huge fortress tower there, and this is the one on the other side of the channel guarding the entrance to the harbour. This was the map which I made with a team of 8 divers from Cambridge in 1958 and 59. Try and imagine this is before plastic tape measures, before GPS, before laser rangefinders, and before a lot of other things. We were given a box of plastic bags by ICI to see if we could find something useful to do with them. They were very useful. This was all done by a very simple theodolite and station pointer. Nick Wood did all the hard work on the design of the survey system. This map has never been superseded, much to my annoyance. I mean, it's absolutely disgraceful that 50 years later, the maps are getting worse and worse. I sometimes feel like a sort of medieval monk who comes back 1,000 years later and find that beautifully illustrated manuscripts have been degraded by photocopying until there's almost nothing left. If you look on Wikipedia, you'll see I had to put this map on Wikipedia because the map that was on there before showed almost nothing. And people keep trying to simplify this and sort of summarize it in a way which is completely incorrect. You have the lighthouse here. The gap between the islands was filled with rubble. These walls on the outside of the islands are what they call wave traps, which is a Phoenician device, so that the storm waves don't break over the islands. There are the slipways. This is what we call the 9 Keys, the grid building. This area had tunnels through the reef with a roof still in place. I've got that on movie. This is a photograph of the 9 Keys by Jean-Pierre Misson, who was born in Libya and swam as a child here almost every weekend and keeps sending me more and more photographs. He's a remarkable source of information. And you can see the masonry structure, and at the end there, the whole of this area was filled in with blocks to make a quay, and there are 9 of these with gaps in between them, and the ships would have come in between them. In 1959, the island, West Island, was continuous. This was a work area for servicing the ships that came up on the slipways. This area is hollowed out. There are caves and so on inside. Every inch of this island is a carved technological creation. In 2003, it looked like that. That wall had gone. Jay Kleinberg took this photograph, and you can see there's a gap about 20 meters, 2 meters thick, and about 5 meters high. There's the wave trap outside, and the waves are now breaking across the island and washing sand onto the center of the island. Jean-Pierre sent me this photograph. It was quite extraordinary. That's one of the lumps of rock from that broken wall which crashed through onto the slipways. The mystery is why nobody knows when this happened. When we were there in 2003, we discussed with the French archaeologists, Monsieur Laronde and his staff, when that wall broke. Nobody knew. The villagers in Massachusetts didn't know. But through correspondence with Jean-Pierre Misson, he sent me this photograph yesterday, which he says was taken in 1967. There's another block lying on the slipway and a diver, and that means that that broken wall at the back was smashed through somewhere in the early 60s, somewhere between 1959 and 67. There are certainly tunnels on Grotto Reef and other things carved through the solid rock, which have also been smashed. The fish tanks here, piscina, this is a piscina loculata, which means that it had rectangular tanks subdivided. It's about 50 meters by 15. That's the walkway where people would have gone round the fish tank to be able to feed the fish and see that everything's all right, and channels with sluice gates to control the flow, which is tidally controlled because there is a tide of about 10 or 20 centimeters in the Mediterranean, and by opening and closing the gates, you can get the water to flush and keep the tank fresh. We found this small marble faun in the tank, in the fish tank in 1959. Okay, up to this point, I've been talking about classical sites, what I call ordinary underwater cities. back to 2,500, 3,000 years ago. As we go further back in time, things start to get more interesting. If a site is unconsolidated, it's not squared blocks fitted together, ashlar, things held together with keys and dovetails and so on, but just earth and bones and flints, will it survive the sea level coming over it? If so, how, where, and when? When I say how many sites do we need, finding one site is just a sort of gimmick. It's a thing. You can't work out very much about a population, about habits, about variability, about hunting or diet or whatever from one site. You need to study a geographical area and find typical sites spread perhaps over hundreds of kilometers. Can we find and study the sites that matter, and what's the best strategy for doing this? Okay, we're now starting to move backwards very rapidly. Just to give you, this is not a detective story in which I keep the solution to the end. I'm giving you the answers as I go along. How many Bronze Age sites do we have in Europe? This is a data set from European project. About 125 sites underwater. Neolithic, that's in the date range 5,000, 10,000 years ago, 750 prehistoric sites underwater. Mesolithic, 1,250. Okay, so we're not dealing with just one or two finds. Prehistoric sites have survived under the sea in European waters in their thousands. Late Paleolithic, this one surprised me when we went through the database, which we've built up in the last few years. We've already got 375 sites older than 15,000 years underwater. There are many hundreds, if not thousands, of sites where people are finding the bones of mammoths and woolly rhinoceros and that sort of thing. This is to show, again, that the subject has been studied for many years. The number of sites that I think is the number readable there? The number of sites here goes up to about 10,000. This is the date starting in the 1800s and coming up to the present. And when the scope of the ice ages was first realized around 1840, McLaren very quickly calculated that if you put so many thousand cubic kilometers of ice on the land, then the sea level will drop by tens, if not hundreds of meters. And a few years after that, people realized that mammoths and tigers and vegetation and rivers and so on would move out onto the continental shelf, and people probably as well. Fishermen occasionally pulled up flint tools or even human bones, which look very old fossils, and people realized quite early on, by 1900, 1920, were publishing papers showing that there was evidence for human occupation of the continental shelf. When we get up into the 50s and 60s, the number of papers begins to accelerate, and now through what we call the Splash Cost Project, we're generating literally hundreds of papers a year on this subject. Again, no mystery, straight to the answer. Where are the sites surviving? These arrows show regions where prehistoric sites survive. They're not single sites. For example, in the Baltic, there's probably over 1,000 Mesolithic and Neolithic villages underwater. There's one site down here in Cape Town. There are hundreds of sites in the Mediterranean, many tens around Florida and the East Coast USA, just a few in South America. The age of sites against date of discovery said people knew there were underwater sites 200 or 300 years ago already, but it's really only after 1900 that they start to realize that they can actually find sites and date them thousands of years ago. These are the names of different sites that you can look up in the literature or in the transcript, which is distributed afterwards, and you can find the references to most of these sites on the web. If we look at the depth of discovery, again, before 1900, it was mostly classical sites and stuff in the Mediterranean, which had been submerged by earthquakes rather than sea level change. And then, as we come forward in time, deeper and deeper until in the around about 1990, a flint tool was found between the Shetland Islands and Norway at a depth of 145 meters. This lovely tool is known as the Sinmar flint. It's actually rhyolite. was found by an American fisherman off the coast of Delaware at a depth of 80 meters of water. And I think there's going to be an article about it in Antiquity by Dennis Stanford in the next few weeks. Okay, the answers to questions 1 and 2 are quite simple. Prehistoric sites do survive, even if they're completely unconsolidated. Just a Bronze Age village or Stone Age Neolithic settlement, which is just wooden hut posts and flint tools and a hearth or fireplace and so on. They do survive the waves coming over them. And we can work out the sort of environment in which they can survive. We can't predict the location of sites exactly, but we can work out already where there's a high probability. And there's a lot of work going on that. Okay, I'm now going to start looking at sites, and the age is going to increase. We're going to start in the early Bronze Age and go back faster and faster until we get to about 1 million years. This is Pavlopetri. I found this site in 1967 and made a sketch map of it, which was published in Nature. And we then got a team of divers from Cambridge University, and I think 1 or 2 from Birmingham and London. And we had a permit from the Eforet of Underwater Archaeology, and the resulting map was published in the Bulletin of the British School at Athens in 1969. You can see, you can see that there's a strong current through here, sand moving everywhere in this channel, and the coloration here, you can see the sand moving over the city and built up there. And there's a rocky ridge there which is protecting the city in that sort of lagoon. This is a photograph from 1967, Kodachrome film, if anybody remembers what that is. The film speed ASA 10. Again, I doubt if anyone under 30 would know what that means, but there you go. It meant that you had to have an exposure of seconds, not quite, well, certainly half a second, to get that sort of picture underwater. You can see there that there are lines of stone which are not squared, but they're quite clearly laid in an intelligent way to make a wall which is about 1 meter thick. These marks are 25 centimeters. Again, 1967 on the top left and 2008 bottom right. The change in color is partly real. Obviously, some of it could be due to the difference between Kodachrome and modern digital photography. But that shows a perfectly clean seafloor and a box grave. You can see it's about a bit more than half a meter long with stones standing on edge. 40 years later, there's been quite a lot of touristic looting. I don't think there's been any systematic looting of the site, but it is a popular swimming beach, and after 3 or 4 days, even children notice these things and bring back souvenirs and show their parents bits of pottery and bones and so on. So the place has been somewhat damaged, and this encrusting sponge appears to grow. When the sand's been lying over the city for many years, it's clean. When the sand moves and stays away from an area for a decade or 2, you get those boring sponges. Another picture from 2008, you see a large rectangular room. We decided, or John Henderson, who got the permit in the sense that there had to be a professional professor of archaeology leading the project. So we had a multi-discipline team from the Hellenic Centre for Marine Research, myself from the Oceanographic Institute, people from Australia, America, a very good team of Greeks and people from other countries working together. And one of the techniques that we were testing was sector scanning sonar. The rotating cylinder there goes round projecting a very high frequency beam of sound in steps of about 1 degree, so that you get a complete map of the seafloor within 100 meters in a matter of minutes. And the resulting map looks like that. This is a 100-meter range, so that's 200 meters altogether. And you can see the main city street going through there, all sorts of side streets and buildings in this area, and the ridge of rock that protects the city there. Further research techniques. Obviously, we had divers working all over the place with sketch pads. That's our daughter Kirsten there, and swimming over one of the big walls, and she was the chief architect for the project in one of the years between 2009 2011. This device was developed specially by Oscar Pizarro from Australia. He has a special unit working on digital robotics for imaging earth sciences, and the vehicle has been adapted so that there's a GPS sensor on the top there, and it can be programmed to navigate backwards and forwards with a spacing of 1 or 2 meters over the site in a scanning system which is completely accurate and would drive any divers absolutely bonkers. You can't imagine people swimming backwards and forwards tracks 1 or 2 meters apart. Took 750,000 stereo pairs in 3 or 4 days' work, mapping the entire city at a scale of 1 to 1. I said in days, but if you look at it, the seabed during the day has ripple patterns on it. The software inside this machine is fitting together thousands of images and adjusting them continuously to get the best possible fit. And the ripple patterns confused the software. So we did it at night. And because the whole thing is with flash, a few nights where you got very accurate photographs and produced an extremely accurate map of the city. And there you can see that diagonal street which appeared on the sector scanning map. A lot of this is reproducing rather more accurately the map which we made in 1967-68, but all this area was discovered new and had been revealed by movements of the sand in 2009-10. Just north of Pavlopetri is the site of Plitra, which I think is possibly older. The oldest pottery found at Pavlopetri is just Neolithic, late Neolithic, perhaps 5,000, 5,500 years old. This site has got standing walls. You can see that the stones are not shaped. Nobody has ever been back there to map this since 1967. I don't know why. It seems to be a very interesting site and could be one of the oldest and most complete Neolithic submerged sites in Greek waters. Okay, we're going back now to 5, 6, 10,000 years, and we need to start looking at sea level change very seriously. During the last million years, there have been repeated ice ages, about every 125,000 years. As the ice, for the moment I'm going to go forward in time, as the ice builds up, the sea level drops down to about 130 meters, and then the ice melts relatively suddenly, and the sea comes up to the present sea level. If you look at the last glacial cycle, the sea level, that spike seems a bit high. The sea level was about 5 or 10 meters above present at the last interglacial. It dropped in a series of cycles driven by what's called the Milankovitch astronomical cycle, and then the sea level rises very rapidly from 20,000 years ago up to about 5,000 or 6,000 years ago. So for the next few minutes, we're going to look at that slope going backwards to 20,000 years. And as the talk progresses, we'll go right back through all these glaciations. I'm sure you've seen maps like this in the popular scientific journals, the DNA data on human migration, and you can see, obviously, that people are crossing sea channels all over the place. On this map, they have not suggested that people cross at Gibraltar or Tunisia, Sicily, but the southern Red Sea, getting into Australia, which was never connected, even at low sea level, Australia was not connected to Southeast Asia, and crossing here at Beringia. I have a sort of love-hate relationship with people who do this work, because obviously the DNA information is staggeringly important. But this kind of map is what I call the broad brush brigade. You take a big colored pen and you put an arrow like that sweeping across a huge geographical area. I'll come back to this topic in a minute. Okay, if we look at the European waters, these are all the key crossing areas, and the occupation of the British Isles. The oldest occupation of Britain is at least 850,000 years ago, near Lowestoft. I'm not sure why, but the people were living there almost 1 million years ago, and it may be even older. This is the oldest site north of the Alps. The crossing areas, I've marked them with arrows both ways. People were crossing both ways, and almost certainly if you lived on the shore, you had people who were skilled, like fishermen today, and knew the channels and knew the currents, and they went backwards and forwards, as it were, just to see their brother on the other side for tea and came back again. That's not a migration. You've got population on this side, a much thinner population over here, and over a few thousand years, because the climate changes on one side or population increases, for every 10 people that go that way, only 5 come back, and we call that a migration. Typical migration, say, from Africa to Beijing 1 million years ago, took place probably substantially slower than 1 kilometer a year. So we talk about migration very often, but really it's a slow ecological diffusion in which the hunting area or migration area with the seasons just slowly changes year by year. A quick run around sites in different areas. A submerged site in the Solent, about 8,000 years old, at 11 meters. The Red Sea, I'll come back to that again later. The Sinmar Flint, 80 meters of depth, over 20,000 years old, and about 100 kilometers off the coast of Delaware. The site here, Monteverdi, has been about 14,000 years old, and I've been looking at the seabed geology here and other sites corresponding with Diego Canabrias, who was in Valparaiso. Caves underwater with paintings, a well in Israel on a freshwater site going down 15 meters below sea level in Atlit, an island in the Sporades, which we'll come back to later. And again, work underwater at Pavlopetri, flints from the North Sea. They're beautifully shaped Acheulean hand axe. The sort of mapping that we can do with that autonomous underwater vehicle. And this, which I love particularly, is an exquisitely carved bone from the central North Sea, about 11,000 years old. And looking at this pattern, you can see that somebody just did that for pure joy. You can see somebody sitting in the sun 11,000 years ago and inscribing this for no function. It's probably a knife handle or something like that, and just showing their skill to make a beautiful tool. Still in the same date range, before 20,000, going out to the USA, Mike Fort has provided this map and the data on the rise of sea level around the Florida coast. Yeah, there you go, the sea level's coming up. The continental shelf in the Gulf of Mexico was extremely well protected and very, very shallow and very low gradient, so that there are Paleo-Indian sites going way out into the Gulf, and sites have in fact been found on both coasts, even on the Atlantic coast where you've got the sea pounding in. The gentle shelving sandy beach protects prehistoric remains underwater. This is Mike's work in the Gulf, and you can see that he's finding prehistoric sites tens of kilometers out into the Gulf of Mexico. Very, very shallow gradient down to a depth there of 12 meters. There's a book coming out published by Springer. The final proofs went to press today. I don't know how long these things take to publish in the modern electronic age, but I would guess it would be on the web or on bookshelves within a very few months. We're back with the broad arrows again. I prepared this slide for a talk in Poland at the end of last year, intending to show the difference between popular magazines, scientific magazines, and serious scientific literature. These are the sort of what I call Napoleonic view of migration, direction nord or whatever. It's not a lie. I mean, these dates are correct, substantiated by very good research. But this is not how people move. This is not how migrations take place. I then did a lot of research in the literature on DNA and human genetics and so on. And they look at that one. That looks like the opening scene of Dad's Army, you know the one with all the arrows. They may take this out of the tape afterwards, but I can't resist it. I mean, really, that is not serious archaeology. And that's, I did a scan through about 50 articles in this literature, DNA, genetics, and human evolution. One paper mentioned the terrain. One paper, which was about migration around southern India, mentioned that if sea level drops and you've got exposed limestone coral reefs, it's not that easy to migrate fast. Nobody else paid any attention to the terrain, the climate, the water supply, the vegetation, the food, or anything else. Okay, migration into America. The Bering Straits here. Some work has been done, really pioneering research there, but one of the key issues is whether people walked across the tundra area when it was glacial, or whether they came, or both, whether they came through the Aleutian Islands by boat. And I wanted to check whether the island topography here has been roughly similar for the last 20,000 years, or whether the land has been coming up, either due to tectonics and plate subduction, or the removal of the weight of ice. So Jay Kleinberg and I took a boat cruise from Kamchatka to Seward in Alaska and looked at a lot of these islands. We landed with Zodiacs, and you can see it's a pretty rugged terrain. There are glacial cirques everywhere. The glaciers obviously melted a few years ago. Incredible volcanics on these different islands, and a lot of wildlife. It's a pretty rugged place. More of these volcanic islands and pinnacles. Again, the base of a volcanic cirque, of a glacial cirque and a waterfall. And one of the guides on the ship found a house pit here, but we were unable, we didn't have enough data to date it, and obviously we couldn't excavate. This is from the Springer book, which I referred to earlier, which I hope will be published in a few weeks or months. And the work by Dixon and Monteleone shows how they are gradually building up the picture of archaeological sites in the area. And what seems to have happened, and the DNA confirms this, is that because the glaciation is always on mountains, you don't get a thick ice cap in northern Siberia or in northern Alaska, because there's no mountains, as it were, to anchor the ice. And the result is that you've got thick ice here in the Ice Age, and the northern part of Alaska was not glaciated. So people seem to have moved, as it were, across the strait, and there was a population here long before they could get down into the main Americas. And then one of the models is that they came down the island chain. Back to Europe. Sites everywhere. The Baltic, as I said, well over 1,000 sites in the Baltic. Neanderthal skull fragments from the North Sea. Several more have been found in the last few months. Acheulean hand axes, bits of mammoth, walls, bones, the well in Israel, caves in Gibraltar. Human material everywhere underwater. The ice sheets covered Scandinavia and northern Scotland, and at different times the ice actually joined up over the northern North Sea. But apart from that, all this grey area, including the Adriatic and large parts of the Black Sea, were occupied by people. You can see models of the way the sea rose over the British Northwest Shelf, around Ireland and into the Channel, and that's the sort of maximum land area. And then gradually the sea floods in and goes round the Dogger Bank and so on in stages. And the press seems to pick up on the Dogger Bank and Doggerland quite frequently, as if it was a high hill with Neanderthals sort of standing on it, signaling for help as the water comes round their ankles. They were not stupid, believe me. The terrain probably looked like that. This is a reconstruction from some Dutch work in the last year or two during the excavation of the new Yangtze harbour. and the total relief in the North Sea is about 20 or 30 meters in hundreds of kilometers. It's really just an undulating plain. And as the sea came over, you would have had mile after mile of marshes like that. Sites have been found all around the North Sea, Orkney and Shetland, bones coming up with the Dutch trawlers. They find about 10 or 20 tons of megafauna bones every year, and quite a few worked flints and implements. Back to Greece, Ios Petros in the Sporades, again around 10, 20,000 years, but the site here is 10,000 years old. Nikos F. Stratiu and Kathy Giangrandi invited Jay and I to go out there in 1981, and to cut a long story short, after a while we found a site where you could put down a 1 meter quadrat, take 5 centimeters of sediment off it, and you ended up with nearly 200 goat and sheep bones. The Red Sea, going further south, right down near Bab el-Mandab, the crossing of the Red Sea, again at low sea level, seems almost certain. The Broad Arrow Brigade now routinely draw arrows across there, although there's no evidence on the ground for it yet. It fits and it makes sense, but that's not quite the same thing as having archaeological evidence on the ground. Starting in 2004-05, with Claudio Vita Finzi, Jeff Bailey, myself, Lawrence Moran, and Abdullah Al-Sharek and others, we started looking around these islands and have built up. The place we're looking at in most detail is the Farasan Islands, and those are the Hanish Islands there. Modeling the sea level rise, or rather running it backwards, that's what it looks like now. And as you lower the sea level, the channel here gets narrower and narrower until there's that tiny little bit there just by the Hanish Islands. This is a very recent bathymetric survey of that channel showing dramatic graben faults down there. Diving around the Farasan Islands, we used trimix, oxyhelium, nitrogen mixtures to dive down to 60, 70 meters. And the extraordinary shape of the islands is due to what's called salt tectonics. As the Red Sea dried out several times, the layers of salt formed and then rock came on top. And then as the salt leached out, you get these extraordinary collapse features, which can go down 500 or 600 meters. And they would have been lakes, probably freshwater lakes, during periods of low sea level. Various scenes during the Farasan Island projects. Divers have been going out there now almost every year for 5 or 6 years. And last year, 2013, we had the Greek research ship with Dimitris Sakalariou, their ship Egeo, taking soundings in those deep wells, deep pits. This is a reconstruction of the most likely crossing point. The Hanish Islands are here. The shallowest point is there, but it's not narrow. It's still about 10 kilometers. And once water is too deep to walk in, it's the width which determines whether people cross it. And that's the most likely crossing point. Gibraltar, a whole lot of caves there, and Clive Finlayson and others, Darren Farr, have been working there for years, also with Chris Stringer, reconstructing the occupation of these caves. I found caves here in the 1960s, and since then we've been surveying them and worked out that this reef is about 30,000 years, or older than 30,000 years, with caves in it, and probably has Neanderthal remains. Australia, in the 1980s, I went out there with Jay, and in fact also our daughter was 4 months old at the time, quite adventurous. She's in that ship. I don't think Kirsten is here. Anyway, the recompression chamber, divers working here. The reefs are about 32 meters, 36 meters down, so there's very little shallow diving. The Cootamundra Shoal comes up to 15 meters at one place, but most of the diving was in 30 to 60 meters. We're about 200 kilometers out from Darwin, and that's the place where we were doing most of the diving and in those valleys. It would have been perfect sheltered conditions, protected from storms, and there would have been mangrove forests and plenty of good food for the Aborigine peoples moving into Australia. One of the maps that we made of the terrain in 1982, Carl Shaw working at 40 or 50 meters with a rock drill. Cross-section of the reef itself, Cootamundra Shoals, and we took a number of coral samples. There's no modern live coral, which means that the sea floor is in effect the Ice Age terrestrial landscape, which was the reason why I wanted to work there. You break through the crust on the surface, and there is coral underneath of older sea level periods when the sea was coming up. South of France, I did a lot of diving here in the 1960s, but unfortunately I did not find this cave, which was discovered by Henri Cosquer in the early 90s. And when he swam up that tunnel, this is what they found inside. For a while, the French authorities didn't believe it and thought that the divers had painted these things as a joke. But not many divers, not many professional archaeologists were prepared to go down 40 meters and swim up that tunnel. But it is absolutely genuine, I can assure you. I love this reconstruction. There's a magnificent book by Clotes and Courtin. There's the entrance to the cave. I dived all around these islands, including 80 meters down one of those pinnacles. It's a lovely attempt and very unusual to try and reconstruct a visual impression of what the landscape was like at this time. But if you look at the scale, that's about 100 meters. Here we have a sort of elk, and the humans are about 10 or 20 meters high. But still, all credit for trying to show what the continental shelf really looked like. Back to the North Sea, we're going back now 100,000 years or more. The Wheeled Artois Ridge joins Britain to the mainland. And this is from Chris Stringer's AHOB project. Britain was joined to the mainland, there's a solid bar there, and was an island only at those occasions. So most of the last 650,000 years, we've been joined onto the mainland of Europe. Mammoth and other bits and pieces come out of the North Sea all the time. This skull is in the offices of Klaas Post in Urk, and many other pieces like that have been found year after year by the fishermen. The English Channel, this map shows the Wheeled Artois Ridge is gone, but you've got all the river valleys coming down into what's called the Channel River, which goes just past Cherbourg here. Cap Lévis, near Fermonville on the chart, there's a granite ridge going out like that, about 1 kilometer or more. On Google Earth, you can see it here. This little rock's called the Bier Rock. Jay and I went out there in 2007, and you can see the current flowing over that reef. When you dive down there are stone tools everywhere. This was actually found and first documented by Scouvet and Verhaeghe in 1978, a really revolutionary document. Hardly anybody's read it. If you look it up on the web, it always cites me as having cited Scouvet and Verhaeghe. But I can assure you, if you can get hold of the original, it's an astonishing piece of work. They studied the solid geology, earth movements, climate change, sea level change, sediment movement, the archaeology, the preservation of the artifacts, and so on, in a volume of about 150, 200 pages. And there are very few projects like that. We've been going back there now to try and sort of reinterpret it with modern instrumentation and modern analytic techniques. And I've been working with the French Oceanographic Laboratory at Ifremer to try and arrange so that we can do some really accurate sonar mapping of the site. That was the map which the French and British divers made a couple of years ago. I don't have the date there. Okay, now we're getting back to really old sites. The Wheeled Artois Ridge is now in place. We're in the North Sea, and the very old British sites are here. Stone tools, Acheulean hand axes, 70,000 years old. And then When the site was investigated by Wessex Archaeology with coring through the sediments, they got down to layers where there were tools or flakes of work flint in sediment layers 350,000 years old in the center of the North Sea. On the shoreline, we have material which is 800,000 years old, quite close by, and you probably saw in the popular press last year footprints found in fossil mud, and that's from the paper, 0.78 to 1 million years old. And they were washed away and destroyed by the storms which came up last winter. But that data has been published showing the footprints of a family walking along the beach at least 800,000 years ago. Cape Town, I went out there in 1995 to give a lecture, and as I was preparing my talk, Bruno Wirtz came up to me and showed me these hand axes which some divers working on a Dutch East India wreck had found by mistake. And nobody locally realized how important it was. I was absolutely astonished and worked with Bruno to get that published. Nature didn't like it, so we published it in the Journal of South African Science, and they are the oldest human artifacts ever found under the sea. To look at the technology that we've been using, I've mentioned diving and sophisticated gas mixtures, autonomous underwater vehicles. The Greek Center for Maritime Research is using both manned vehicles and robotic vehicles. Gas mixtures when diving are very important. There's no point in taking a PhD diver, making them breathe air so that they're back to sort of 2A levels at 20 meters, O level at 40 meters, and kindergarten at 50 meters. So give them a good gas mixture so that they preserve their IQ. Acoustic methods, astonishing techniques are now available for mapping inside the sediments and to reconstruct incredibly accurate topographies of marshes, swamps, shorelines, caves, and so on, both within the sediments and on exposed bits of the seafloor. This is a fabulous reconstruction of the Portland Bill is just here, rocky headland. The eddies which go round here, that's 2 kilometers, form this fabulous, huge, sort of dynamic sand dune, which looks almost alive. You can see the sand waves and currents are rippling off it. Underneath the mobile sediments, you've got the bedrock. You can see the dipping planes of rock. You can see the faults in the bedrock. And even there, a river valley going through the rock, an incised meander. You've probably got 500,000 years of climate and geology in that one image, all done by acoustics. That would have been absolutely impossible 20 years ago. Okay, I asked how many sites would be needed. Ideally, you want tens of sites in 100 kilometers square. There are whole continents where we've got one or none. The entire southern route from the southern Red Sea round India, Southeast Asia, and Indonesia, there are no known submerged prehistoric sites. And yet it's obviously staggeringly important, both for human diffusion through the Asiatic continent and for the occupation of Australia. We are finding them, but the only area where you can do what might call modern archaeology, studying dozens of sites, thousands of artifacts, and changes spatially and in time, are in the southern Baltic, parts of the North Sea, and the coast of Israel. So there's an enormous amount of work to do. If we look at the numbers of sites in Europe, this is from the Splash Costs database. You can look these things up on the transcript. There's over 2,500 sites, and some missing. Not all countries have returned their data. We can look at them distributed by age. As I say, when the data came in, I was quite astonished how many were in the late Paleolithic. And also you can see that material survives in very widely different environments. The Yugoslavian coast is sort of rocky and steep with dozens of islands. The Baltic is all sediments and mud and low islands. The coast of Israel is straight sandy beach with 1,000 kilometers of fetch of waves breaking on it and so on. So sites can survive in all sorts of different geomorphological environments. The map on the right showing, or the diagram on the right showing the diving depth, is a little bit conservative for air diving. You can probably work down to 20 meters quite well on air, but nitrox around 20 to 30 meters to reduce nitrogen narcosis, and then trimix down to 80 or 90 meters. Up to this point, no prehistoric site has been excavated or studied in detail by any means other than by diving, although we're obviously working on robotic techniques. Finding the sites that matter. Again, we're putting together a strategy. We're getting there. The systematic research strategy is only just being developed at a continental and global scale, but we are working on it. Don't try and read all the small print. This is an outline of the strategic methods that we're developing for European programs funded through the Commission to study different aspects of prehistoric archaeology around in the European seas. And I'm now chairing a working group known as Subland, which is sponsored by the European Marine Board, has representatives from about 15 different countries, and is working with the European Archaeology Council to develop a multidisciplinary research strategy looking ahead 5 or 10 years. We have no authority to actually decide policy or instruct anybody to do anything, but I hope that the combination of skills that we're bringing together, the range of experience, the results of surveying national policies for submarine prehistoric research through the national heritage agencies, plus all the technology and skills from the oceanographic laboratories of the Marine Board, we can show that the strategy we're putting forward is sensible. Thank you very much.